Section 7.4 is called percents and interest. It's really more like two sections stuck together. So to start with, we're going to talk about the idea of percent. The word percent comes from the Latin word meaning per hundred, as in our cent. Think about when we talk about 1 cent. It's worth 1/100th of a dollar. That is when we write in percent, we mean in over 100. So you think about a penny, right? So if you have 5 pennies, that's 5/100ths, 5 over 100 of a dollar. And that's where percent, the word percent, comes from. There are 3 methods. Your book only actually talks about 2, but I added one in because I think it's more common than the book maybe. Well, they just didn't even use it. So there are 3 methods for turning percents into sort of a decimal expansion. So the first one is to take the number that you've got. So this one they gave us is 7.9. And you're writing it as a number over 100. And that's what you're really doing. So if you think about it in some sense, it's already a number over 1, and you're multiplying the top and the bottom by 100. And then you're recognizing that once it's in that form, the number over 100, that is the form for percent. So this is 790 percents, or per hundreds. That's what that actually means. And I know that this is sort of an awkward number to talk about it with, but we can still use any number we'd like. The second way is to use a proportion, and a proportion feels very awkward on this question, and I totally get that, but there's an example I'm going to show you later where it feels more natural to use proportion. You'll see why. So the idea of being is you're going to set that 7.9 over 1 equal to n over 100, and then what do we do when we have a proportion?
Cross multiply.
Right, we would cross multiply. And so you would end up getting 1n, or just n, equal to 790, and that n would be this percent value then, so this would be 790%. Those are the 2 methods that your book shows, which is probably neither one of which you've done the most of. The one that I find people do the most of is they simply move decimal points. So when you turn something into its percentage, you move the decimal 2 values or 2 place values to the right. So 7.9 would really be like 7.900 and more zeros after that. But we're just moving the decimal point 2 locations to the right, and we end up with 790%. All right, so what we're going to do next is we're going to take a couple of examples, and we're going to actually turn them into percents. So we'll do the first one, whichever one you want. I'm going to do part B in a proportion form because that's the one I wanted to show you in particular that works really nicely. So what would you like to do with the 42.6? What was that? The first method? To write it over 1? So the part that I didn't actually write down on that previous slide is this idea of multiplying by 100 then. So what happens when you take 42.6 and you multiply by 100? What do you get? Yeah, 4,260. So what is the percent here? Yeah, it's awkward, funny sounding thing, but it's a 4,260%. 4,260%. Because it's per 100. Okay, percent means per 100. Part B is a really good example of one where a proportion works nicely. Because if you don't use a proportion, you end up having to turn this into a decimal anyway. So one way or another, you're going to end up with a decimal form involved here. So to do this in a proportion form means to set it up as equal to n over 100, and then to cross multiply. So if you cross multiply this, you get 3n equal to 800. And then what? Divide by 3. And what do you end up with?
266.
Oh goodness, we got that 6 repeating business going on, huh? All right, 266.6 repeating percent, which is a fine way to write it. It's okay. We can't put the 6 repeating in front of the decimal though, right? It's got to come after it. So the part that repeats, we recognize the 6 is repeating before this, but the decimal value is where it needs to show up. Okay, so this is taking a number and turning it into a percent. All right, we're going to go the other direction as well. We're going to take a percent and turn it into a number. So there's a couple of methods to turn percents into numbers. The first one is to simply divide the number by 100. So for instance, I guess I didn't write an example down on this. I've got one in a minute. But if you were taking the number 4.1% and you wanted to turn it into a number, then you would simply take the number 4.1 and you would physically divide it by 100, right? So like, 100 on the outside, 4.1 on the underneath the bar, or using your calculator, you're actually doing a division problem. So this is one way to do this. The second way is to take that value, again, and move the decimal 2 places to the left. So again, if I've got my 4.1, then 2 places to the left looks an awful lot like this, and there's not even any numbers over here at the moment. There's going to be a 0 there, and then we'd end up with the number 0.041. So this would be the number that corresponds to 4.1 as a percent. Okay. All right, so we're going to give a couple of them a try. It says to convert each of the following into a decimal. So I'll do one of them with method 1 and one of them with method 2. I don't care which one. So you guys decide. Which one would you like to do with 4.5? What, Haley? Move the decimal. I don't have a decimal right now, so how am I going to do that?
I was going to ask, how would you do it with method 1? Can you just show us how to do that?
How would you do it with method 1? Okay. So we're going to do a method 1 on one of them or the other. So here's I didn't mean 4.1. 4.5%. That looks better. Right, so the 1/2 is 0.5, right? That's the decimal that goes with that. All right, so we're wanting to turn this into a number. So method 1 means that I take the 4.5 and I divide it by 100. You're welcome to use your calculator to do that division. We should be able to do this division pretty much okay on ourselves too, though, right? So the decimal point comes up here, and then we would look at it and would say, oh, look, I need to have my 4 over here. So 4 times 100 is 400. There we go. There's a 0 there. And then I've got 50 left over. I need another 0, and then I need 5 times 100 to give me 50. I've been working a lot of long division with my daughter recently. She's tired of dividing with so many values. So this becomes 0.45. I'm sorry, 0.045. Let me say the number right. So 45 thousandths, right? All right, so what would we do if we do the other method with 125? Okay, so again, I don't see a decimal place, Hannah, so what am I going to do? Or where is it? Yeah, it's just after the 5, right? All right, so where am I going to move the decimal point? 2 places to the left. So that would be right here. So this 125% becomes the value 1.25. Very good. And I'm not even sure that in your book it tells you which method to use where. I just want you to be aware that different curriculums will focus on different things. So if you happen to come across a curriculum that looks a little different than what you've done, it's okay. Just be aware that those things are out there. Is there a question? All right. There are some applications we're going to use. I mean, the whole point of being able to do these percents is to use them in practice, in application, real life stuff. Percents are very useful in real life. So we're going to look at 3 different kinds of applications or forms of applications that use percent. The first example is finding a percent of the number. And so these are just going to be real simple, like how the phrasing looks when you see this. So you get something that looks like this. What is 15% of 32? Okay, that's not a context question, but that's what that's what the question would boil down to, is finding what is a certain percentage of something else. Okay. Another question that we can ask is to find a percent, the percent one number is of another number. So for example, something like this. What percent of 47 is 12? This is what we do on your homeworks every time I hand back a homework. I turn them into something that's a percent. I write it as a value out of 10, but it's a percent, right? You guys look at that and you know what a 9.2 means. It means I got 92%. This is what I do. I find out what is the percent you got out of 18 or 16 or 22, whatever the number of problems were graded, okay? Another one, oh, the first one I didn't give you an example of when that happens. You might be able to think about that when you're talking about a sale. You probably ask it in a little bit different way, but you want to know usually how much am I going to have to pay for this shirt, right? It's 15% off. How much am I going to have to pay for the shirt? Well, it's very similar questioning to asking how much am I saving on this shirt. That's question number one, or modeling number one. All right, model number three, or form number three. Finding a number when a percent of that number is known. So something like this: 13 is 45% of what number? This is what you would do. Sorry, Andrew, I'm focusing on shopping because you use percents a lot in shopping. You might not be too excited on this one. Shop for something good. This is what you would do if you were trying to justify why the amount of money you spent on something was such a good deal. Right? Like, I saved, whatever, and you're like, oh my goodness, but the original price of that dress was like $200. Like, I made a great deal. Yeah, I know I spent $40 I didn't have, but man, I saved so much money. Okay, so this is the percent of the original price. This is what this is giving you. All right, so what we're going to do is we're going to do some examples of these, and your textbook is never going to ask you what type of problem is this, but I do want you to see that you're using them, so that's why I'm asking it at the bottom. So that's you're not going to have to do this part of it later, but just something to be aware of is that you use these different application types in all kinds of language. So here's our first example. What is the sale price of a softball if the regular price is $6.80 and there is a 25% discount? Now, there are multiple ways of doing percent problems. Your book focuses in this section on using proportions. And it's a really, really good way to focus on it because it gives some structure for kids that's not dependent upon language. One of the sort of, be it good or be it bad, is that a lot of times we think like words mean certain mathematical operations, except when they don't. And then it gets confusing, right? So we say of means multiplication, but then we use it somehow else and it didn't quite mean that. Well, the nice thing about using these in a proportion form is that the form is automatically there for you. So let me show you what I mean. We're going to set up a proportion, and the proportion is always going to have a percent on one side. So the first problem that you're going to have, every problem you're going to have is going to have this one with the 100 as the denominator. Okay? The numerator on the right-hand side is going to be related to the percent that you were given in the problem. I say related to because it's not always exactly the percent. So let's take a look at this one so you can see what I mean. It wants to know the sale price of a softball if the regular price is $6.80 and there's a 25% discount. Now there's two ways to interpret that. One is to use the 25%. So let's use that, and then I'll show you the sort of the caveat of doing so at the end. So the 25 goes right here. Okay? So the percentages always go on, I'm using the right-hand side, it could go on the left, but they go always on one side of the equation. The other side of the equation, these two pieces are the original versus the sale price, or the full amount versus the partial amount, whatever it is you're comparing. So in this problem, where does my 680 go? It goes on bottom. It's the full price. If you think about it, it's telling you that it's related to the 100%. That's what it's doing. All right, and what we don't know then is the sale prices, which is what's going to go on top. So then how are we going to solve this problem? Oh, we're going to cross multiply. So we get 100x on one of the diagonals. What is the other diagonal going to equal? And I don't have this one written down, so somebody's going to have to tell me. 170? Okay. Okay, then what would I do? Divide both sides by 100. What does x equal then? All right, so first of all, a good notice is some of you are saying dollar, that's good. And then, of course, when we're talking money, it makes sense to put 2 decimal places. So $1.70. Now, I need you to pause for a second with me and ask yourself, did you answer the question? No. What did we actually find? We found out how much we saved, right? So if we go through this problem, at the very end, we have to be very careful that we go back and answer the question that was asked. So what would I find out for my actual, my new sale price? So we'd take 680 minus 170, and what would we get? 510. So is there anything terribly difficult about doing the subtraction at the end? No. The only difficult thing is remembering to do it. because sometimes we get to the end, or what appears to be the end of the problem where we have x equals something, we think we're finished. So if we didn't want to have to remember at the very end to do something like this, any other ideas about how we could do this?
If you didn't have to use proportions, then you could just times.
Okay, we are going to still use proportions, but we're also going to use what you suggested. What did you? Use 75, yeah. So we're going to start the problem very much the same way. We're going to put our x over my 680, and we've got the 100 over here on the right, on the denominator. But instead of using 25, we're going to use 75. Now, where did 75 come from? Right, if there's a 25% sale, then you're paying 75% of the price. That's where that's coming from. Okay? So if we sort of take the initiative at the beginning, we can make that determination before we ever get started, then we don't have to worry about remembering it at the end. So we still have the 100x. This time, though, we don't get, 170. What do we get? 510. And then when we divide by our 100, we already get the actual sale price, which is $5.10. Okay? All right. What type of problem was this? Is that our first one? Yeah, it is, right? Yeah. Yeah, the first one. This is finding a percent of a number. So this is problem number 1, or problem type number 1. All right, question 4, example 4. A ski area reports that 80% of its runs are open. If there are 60 runs open, how many runs are at the ski area? Okay, so just like on the last problem, we're going to set it up with a proportion where there's a 100 in the denominator, and I'm always putting my percents on the right. You can put them wherever you want, but yeah. All right, so what am I going to put in where?
60.
All right, 60. Where's the 60 going to go? Denominator or numerator? It's actually the numerator. Why will the 60 go in the numerator?
It says like 80% open and 60.
Okay, so the 60 is like a smaller portion of what's open. It's not 100% of the runs, right? It's a smaller portion, in this case 60% of the runs, or 80% of the runs. So in fact, this is the value I don't know then, right? The 100% value. What's going to go in my missing place? That's my 80. The percents always go on the same side, so the 80 will go above the 100. And then we're going to cross multiply. Have 80x equals 6,000. And what do I get when I divide this by 80? 75. 75 what? Ski runs, at least runs, but we need to have something in there in terms of the language we're talking about. Since there's word problems, there's at least some contextual answers. What type of problem was this? 1, 2, or 3? It is. It's number 3. The difference basically between number 3 and number 1 has to do with whether or not we're given the numerator value on the left or the denominator value, doesn't it? Do we know the amount of the sale or do we know the amount of the original price? That's the idea. All right, one more. Mort. Mort bought his house in 2008 for $159,000. It was recently appraised for $195,000. What is the approximate percent of increase in the value of his house to the nearest percent? You'll notice there's something distinctly different about this one than the other two. What is it? There is no percent given, right? So that is what we're going to be finding, which makes it a problem number 2 type. Okay, this is a number 2 type problem. So in terms of setting up my proportion, I'm going to have the x over here and the 100 here. Everybody good with that so far? Okay. All right. Now what? What's going to go in the other places?
The 159 goes on the bottom.
Okay, the 159 goes on the bottom. Why?
Because it's the original, so it's the 100 because our percent's going to be over.
Right. So the 159,000 is the original price of this particular house that Mort bought. So you're exactly right, Amy. That goes on bottom. Now we have 2 options for what goes on top. We can put 195,000 on top. That's okay.
I guess you could look at
But if we do that, when we get to the end, will we have the answer? We won't, actually. We'll have to do something else to get the answer, like our softball problem.
Yeah.
So the other option is we could subtract the two values and put that as our numerator. Because it doesn't ask me for the percent value of the new house. It asks me for the percent of the increase. Did you notice the language? So either one is a perfectly acceptable way to do the problem. You just have to be aware of what you're doing and which one you're actually looking at the time. So do you guys want to do the subtraction value or you want to do the 195? Subtraction? Okay. So the percent increase, or the value increase for now, actually, first. Would be my 195,000 minus my 159,000. So how much of an increase is that? 36,000. So the price of the house has increased $36,000. Or not the price, but the value according to this. Okay? This is a nice way to do it because the answer ends up being what we're looking for when we're done, so that's kind of friendly. All right, so what are we going to do? Cross multiply. So this one's 159,000 x equals 3,600,000 on the right. Then what? Yeah, divide by 159,000, and you're going to put this in your calculator, right? Because I'm not doing this one by hand. X is what did you get? Okay, now let's go back up to the directions one more time. How does it want our answer reported? To the nearest percent. So how are we going to alter what you gave me, Kayla? Right, so we're going to go ahead and report the answer to the nearest whole percentage, which would be 23%. So it's a 23% increase in value on the house. Now, what do you suppose the answer would have been if I had 195 on the top? It would be 123%. That's exactly right. 123% of the original value, hence a 23% increase. So it's not like it's terribly complicated at the end. It's just something to be aware of that at the end you have another step to do. Okay? All right. Yes?
If it doesn't say specifically where to round, where do you want us to round?
Usually percentages, if not otherwise indicated, one decimal place is fine. Yeah. Okay. We're going to do a little bit of mental math. So here's the catch about mental math. Mental math occurs where? In your head. And I can't see in there, which is so unfortunate. It would really be helpful to be able to see, like my kids. I wish I could see in their heads sometimes. That would be nice. Actually, it might not be nice. I might not like what I see. Okay, so here's the catch with this. So when you're doing the mental math, you're going to have to write down a little bit of what's going on in your head so that I can know how you're thinking about it. And not because there's like always one specific right way, but that way I can see how you're viewing it, and it also gives you opportunity to explain something in a math sense or whatever, for like partial credit kind of stuff too. So things. Okay, so let's take a look at 15% of $42. Any idea how you might use mental math to calculate 15%? Okay. You're thinking about that in specific relation to the $42, aren't you? So I want to think about 15% of any kind of number, more generally than what you're thinking of.
10% is 4.2.
Okay.
How about another half then?
Okay. So you're thinking maybe of taking 15 and breaking it down into sort of pieces, right? Sort of breaking 15 into 10 and 5, right? I think that's a good approach. So if we were to do this, we can sort of think about finding 10% of something and 5% of something. I like finding 10% of some things. How about you?
Yes.
Yes. So let's figure out what would we get for 10% of $42. Again, we're not trying to use proportions. We're trying to do mental math here. So what would 10% of 42 be?
4.2.
4.2. Now, using that, can I get 5%?
Yes.
Yeah. So 5% is half this. So that would be 2.1. And then we add. So you got 6.3. And maybe like a dollar sign, right? Because this had dollar signs at the beginning, didn't it? Yeah. So it's not anything terribly complicated on what you're writing down. You're just writing down some brief phrases of what's going on in your head as you're doing the problem. What do you think you might do for 20%? So you could break it down. What was that?
Could you just divide 280 by 5?
Yes, you could. That's another option. I will write that here as well. We'll do it both ways, okay? Okay, so one option is to break it down kind of like we did on the first one, did 10%, 10%, and then add them together, or 10% and multiply by 2. So what would you get for 10% of this?
28.
And then we can double. So what would double 28 be? 56. Dividing by 5 is really nice too. It may not be especially nice on this particular one because of the 8 being a little bit awkward, but it's not bad. So 20% is 1/5 of 100, right? So like if you take about, I think there's, are you guys with me? Like there's 5 20s in 100. So you could divide by 5 to do this as well. And again, this is a reasonable thing. I think most people could process through this, or at least see where you could process through this if you could in your head. So you're getting a 5 here, right? And then this would be 25, and then 30 would give you 6, so you get 56. So either way, those are both very different ways of doing the problem, but they both work very well, and are both totally legit mental math. All right, what about 5% of 32? Okay, so we could do 10% and half it, right? Got a little bit of a lag time going on with my screen, I'm sorry. So what would 10% of 32 be? Right, 3.2. And then we half it. So we're dividing it by 2. I know you don't usually see division by 2 written that way, but that's because I'm special. Okay, so what is 3.2 divided by 2? It is, it's 1.6. And again, $1.60 if you want to write it with the decimal form. We can put a 0 on the end. Part D is an interesting one. There's, again, a couple of ways that you could do it. So
I'll just divide it in half and divide it.
that's one way to do it. So you would half it. So I'm going to give you 3 ways then. We're going to half and half again. So dividing it in half gives you 50%, and half again would give you 25. Somebody else tell me something else you could do.
Divide by 4.
Yep, you could divide by 4, which is the same as dividing by 2 twice, right? There's one other option. This is my least favorite option, but undoubtedly somebody always likes to do it, so it's okay. Mm-hmm. So they find 10% and they add it to itself, and they find the 5% and add that one to it. That's the longest method, but it still works, and you could still think that somebody could do that in their head. 10% and 5% are not hard calculations to do. So I'm going to do the half and half again. I think you guys know how to do this in general, but we'll just do one of them. So if I took 84 and I divided it by 2, what would I get? 42. And if I took 42 and I divided it by 2, I get 21. And obviously, depending on the values, will depend on how easy it is to either divide by 2 or divide by 4. This one divides by 4 really nice because it's 8 and 4. I mean, like, that's great. But sometimes, honestly, dividing by 2 twice makes a lot more sense because the division by 2 is something that's easier for our brains to do. So, any questions on that one? Okay. I have one more question that's specifically about percents in this way. Why is it possible to have an increase of 150% in price, but not a decrease of 150% in price?
Prices can't be together.
Okay, so if we tried to decrease something by 150%, it would become negative, right? So I will tell you that I have had that happen before at a store where it came up as a negative value, but it was because of coupons, not because of percentage off things. Okay, so it's not that, and they wouldn't give me back my 8 cents. They actually made me buy something else instead.
Are you serious?
I am serious. Yeah,
That's all they do on TLC.
crazy, right? Yeah, I
I've
know.
seen that on,
Those
like,
coupon
yeah,
shows.
The coupon shows.
But yeah, when we're talking about percents, though, that doesn't work, right? We can't turn something, find the percentage, and then actually end up with a negative value. That doesn't work. So why can we do it with an increase?
It's just half the price in addition to like, so if it costs $10, it'd be 15.
Okay, but that would be, so, yeah, so say that again louder.
So if you have 100% and that's like $10,
Uh-huh.
150% of that price would be $15 because it'd be half of it again.
Yeah.
Added on.
Inflation is what you had said. You also have something here called markup. So it's like how much the store is going to charge for some kind of an item or something like that. The issue is whether we're adding or subtracting. I mean, that's the real kicker here, right? You can always add more to a value of price of something, but really the lowest price you're going to get is somebody giving it away to you for free, right? They gave it, and even that doesn't happen in stores. You might buy it for less, but it's usually not for free. So yeah, it's this issue of this negative stuff. All right.